Why do we need autonomous buildings? Like, what are the other problems with controls specifically, besides the fact that buildings aren't energy efficient and they drift, like you talked about earlier? What are the issues with the actual old style of controls?
So there's the entire continuous commissioning aspect, which we already spoke about. And yes, at the beginning, that was the target. But then we realized that if we're able to predict the future of what will be happening in that building with a super high accuracy, or about 99%, we basically know the future. And when we realized that the deep learning algo were giving us that accuracy for hours and hours ahead. So we knew that in 3 hours, that room will be too hot. It will hit the cooling set point in 3 hours, in 4 hours, in 6 hours. And we realized we had that luxury to basically know the future of that building with a very, very high accuracy. We went like, wow, I mean, we could do more than continuous commissioning. We could basically design our control strategy right now to have a better future. And it's kind of going into this concept of, when you think about it, all of our HVAC right now, they're reactive. And even if you use a PID loop, you're reactive. So there's something which is happening now and you're reacting to it. But you're already into that climb, or that in that descent. You're already going through that event. You're not into the past or looking at the future. You're really into the present. And all of our HVAC system are reactive. I mean, they are programmed which, if this value trigger this action until you have this other value, then you could release or you could stop whatever action you were doing. The entire logic of our programmation is like that, is reactive. So it's kind of similar than if you were driving a car and I was blocking your windshield with like piece of wood or whatever. You're basically allowed to look on both sides. So you see what's happening right now. You're allowed to look in the past. You have your rear mirror, but you're not allowed to look in the front of the car toward what's coming at you. So you'll be going through all kind of surprise, and you're going to react to these surprise, but you're already going through that surprise. You don't anticipate. So if you were driving like that, it would definitely cost you more energy, because you were not able to anticipate, should I accelerate or slow down or just let it go. And it would be very, very uncomfortable for whoever passenger is with you in that car. And I will not mention the damage that you're probably going to create on your car.
Yeah, it sounds terrifying.
But that, when you think about it, all of our HVAC system are acting like that because we don't know the future. So we're following the schedule, we're following action that are happening already, and we're reacting to these action by a reaction, and we're trying to stabilize as we go. So knowing the future, suddenly we could start to do preemptive action that would either improve the comfort or reduce the quantity of kilowatt that are spent to react to an event. And when you're at full throttle, let's say it's super hot in the summer or it's super cold in the winter, and the system are at maximum capacity, knowing the future is not really helping you. You're already at maximum capacity. You will be running at maximum capacity for the next 3 hours. You're not going to save anything. But there's a lot of other period during the year where you're not running at maximum capacity of equipment. And knowing what's going to happen, you could do preemptive action, which will save some money and at the same time will reduce the discomfort that these action and reaction are creating.